Okay. So as I've told you before, we are going to we are going to the next subtopic, which is elasticity. I cannot. Oh, hold on. Okay. So under elasticity, you should be able to describe elasticity, and you should be able to do experiment to investigate relationship between force and extension of the spring. And then you should be able to communicate about the law related to force and extension. Okay, and also solve problem involving force and extension of the spring. Okay. Okay. So as you can see here, a man pulls an elastic cord during an exercise routine. After his exercise, the cord returned to its original length. Okay, what property is shown by the elastic cord? So this is the question. The man is pulling the elastic cord during exercise routine, but when he let go of the uh, cord, or when he leave the force exerted onto the cord returned to its original length. So this is called elasticity. Okay, so as you can see, this man found a spring. Okay, don't know what to do with it. Leave the spring, and then as he compressed the spring becomes shorter. Okay, so he get an idea. What do you think he do with the spring? Now, what do you think he would do with the spring?
Pull or compress the spring.
Okay, pull or compress the spring. So, what do you think he will do next? Apa agaknya nak buat? It's quite a big spring. Apa? Okay, let's see what he do with the spring. He used the spring to play with it. Kan ada orang yang apa nak panggil ni pun saya pun tak tahu. Duduk atas spring tu dia time atas spring tu. Okay. So okay. So a diver jump from a springboard. Why does the board bend when the diver stand on it? What will happen to the board after the diver jump into the swimming pool? So the first question is, why the board bend?
Because
Because
the
the
diver
stand on it, there's a force exerted on it.
Okay, when the diver stand on the board, there is a force exerted onto the board. Okay, so but what happened when the diver jump into the swimming pool?
It will go back to its original.
Okay, so the board will go back to its original state or original length. Okay, so Ivy, let's look at the first activity here. The aim is to generate idea on elasticity. Okay, so number one, pull in sequence rubber band, spring, and sponge. So what do you think when the rubber band, spring, and sponge is being pulled? Ivy? Yes, Ivy? What do you think will happen?
Both three objects will change its shape.
Okay, so all the three objects will change its shape. So how does it change? Will it become shorter or will it become longer?
Longer.
It will become longer. Okay, the length increases. So when the applied force is removed, what happened to the object? Kalpana.
It returns to its original shape.
Okay, so when the force is removed, it returns to original shape or length. Okay, so now we have plasticine. When we press plasticine with our thumb, what do you think will happen? Kinisha? Kinesha, we used to play with plasticine, kan? So what will happen when we press the plasticine? Yes, Kinesha? Uh, Kalian, help Kinesha. What happened when we press the plasticine with our thumb? Lian?
Ja,
Yeah?
Kanisha texted that it changes shape.
Oh, I forgot to look at the chat. Hold on, it changed shape. Mic's not working. Never mind. Okay, so it changed shape. How does it change shape? You press it. So what will happen to the shape? Will it become rounder? Will it become flatter or more specific?
It becomes flatter.
Okay, it becomes flatter. Okay, the plasticine will become flat. And now if we remove our thumb from the plasticine, what do you think will happen? Will it become its original shape or will it remain flat? Kasih.
It will remain flat.
Okay, it will remain flat. It won't change back to its original shape. Okay, so the question is plasticine an elastic material? Nikita Divan. How to pronounce your name? Nikita. Am I correct? Yes, Nikita? So is plasticine an elastic material or is it not? Okay, yes, plasticine is an elastic material. It's not an elastic material. Okay, so plasticine is not an elastic material. Okay, so based on the discussion on the two activities, what can we say about elastic material? What can we describe or how do we define elastic material? Can someone give definition of elasticity? So what is actually elasticity? Or how do we define elastic material based on the two activities that we have discussed? Renuga? Yes, Renuga, if you might have problem, you can write your answer in the chat area. I left the meeting. So, how do you explain or how do you define elasticity?
Elasticity is the property of an object to return to its original shape or size after the force applied on it is removed.
Okay, can you hear me?
Yes.
Okay, sorry, because I got disconnected just now. Let's continue again. What is the definition of elasticity? So, just now, someone wrote, okay, yes, so?
Elasticity is the property of an object that enables it to return to its original shape and size after the force applied on it is removed.
Okay, so elasticity can be defined as, oh, sorry, ability or property of an object to return to its original length or shape after external force is lifted or removed. Okay, just now someone wrote on chat, elasticity is object that can be compressed and extend, if I'm not mistaken. Sebab tadi saya left off, so the chat area is empty now. Okay, so elasticity is defined as ability or property of an object to return to its original length or shape after external force is being lifted or removed. Okay, hold on. I need to record this again. Oh, still recording. Okay. So, let's say we have two situations here. We have two diagrams, diagram 3.1 and 3.2. Okay, so let's say this is 3.1 and this is 3.2. Okay, you are given this situation. Father and his son sitting on two
Teacher,
identical, yes?
you are not sharing the screen.
Oh, okay. I forgot. Selalunya saya tak pernah terkeluar, tapi tiba-tiba hari ini terkeluar pula. Okay, so can everyone see the PowerPoint?
Yes.
Okay, so okay, let's look here. We have a diagram. Okay, so this one is 3.1 and this one is 3.2. For 3.1, the son is sitting on a bird nest swing and this one is the father. Okay, so the swing is identical. The spring of swing are extended when set by them. Okay, so this is the upper magnified diagram of the spring. Okay, so this is the son. Okay, this is the father. So what is the inference that we can, what inference can we make from the situation? Anybody? Let me call upon Abiramitiaga.
Yes, teacher.
So what inference can we make?
The force exerted influences the extension of the spring.
The force exerted
Influences the extension of the spring.
okay, influences the extension of the spring. Okay, when we do inference, we can give a general relationship. Okay, so like Abirami said just now, the weight influences the extension of the spring. Okay, or we can write the extension of the spring depends on the force exerted. Okay, also we can also write the inference like this. Okay, so we write, we give a general relationship. Okay, we say that this depends on this. Okay, as for the hypothesis, Archana.
So the greater the force exerted onto the spring, the greater the extension.
Okay, so the greater the force exerted onto the spring, the greater is the extension. Okay, so or the higher the force, the longer the extension. Okay, so the hypothesis is a more specific relationship. how does the force affect the extension? For inference, we write general relationship. We say that this one influence this one, or this factor affect this factor. Okay, but as for hypothesis, the relationship must be more specific. Okay, so for your paper 3, for your experiment, okay, you might be given this type of question. You might be given a situation where you need to write inference and you need to write hypothesis. Okay, after that, you need to do the experiment based on the situation given. Okay, so I presume the question for paper 3 would be like this lah. Okay. Okay. And when we do an experiment, other than inference and hypothesis, we also must write the aim of the experiment, and also we need to determine the variables of the experiment. Okay. As for the aim of the experiment, what do you think would be the aim, Danushini? Danushini? How do we write aim for experiment? Yes, if your mic is not working, you can write your answer in the chat area. Okay, to determine the relationship between extension of the spring and the force. Okay, so that would be our aim of the experiment. Okay, to study or determine relationship between force and extension of a spring. Okay, so for paper 3, okay, other than inference, you should be able to write the hypothesis, and also you should be able to write the aim. Okay, when we write aim, usually the aim is to investigate or determine or to study relationship between two variables. Okay, now what would be the manipulated variable, Ashley? Okay, Ashley, what is the manipulated variable here? Okay, manipulated variable, the size of plasticine. For variable, we must give a physical quantity that can be measured. Okay, if you say size, it's not that accurate. Okay, mass. Yes, mass can be used because we can measure mass clearly, or we can measure mass accurately. Okay, so the manipulated variable mass. Any other answer for manipulated variable other than mass? Okay, mass is measurable. Okay, force. Okay, so for our hypothesis, for our inference, and for our aim, we write force and extension of spring. So when we write our manipulated variable, mass is actually correct. However, from the starting, from the inference to the aim, you use the word force. So for manipulated variable, you cannot simply change to mass. Okay, because it is different physical quantity. Okay, so the best answer is the force. Or we can also write weight. Weight is a type of force. Okay, so what is the responding variable? If force is the manipulated variable, what would be the responding variable? JC.
Tension of the spring.
Yes. Tadi,
Tension
where
of the
when?
spring.
Extension of
Yes.
the spring. Okay, because we use the word extension of the spring for our aim, for our inference, and for our hypothesis. Okay, we need to be consistent from the inference. It should be the same variable. Okay, for inference, maybe is a bit apa longgar lah, because inference usually based on situation. So maksudnya kalau awak nak kata apa extension of apa tadi buai tu pun boleh juga, because for inference is more related to the situation. But starting from hypothesis up to our variables, we need to use the same physical quantity. Okay, so what would be the fixed variable? Fixed variable, Fatana. Apa yang mesti fix? Yes, Fatana? What should be fixed? Okay, we manipulate the force, the extension of the spring will be responding. So what would be the fixed variable? What do you think is the fixed variable, Fatana? If you can on the mic, or you can write your answer in the chat. Irdina, what is the fixed variable?
The stiffness of the spring.
Okay, the stiffness of the spring. Stiffness of the spring. Okay, so for variable, as I told you before, it must be something that can be measured using apparatus, a measuring apparatus. Okay, so like force, we can use spring balance and so on. Like extension, we can use ruler to measure. Okay, for stiffness of the spring, it is not something we can measure directly using a measuring apparatus. Okay, so or if you write type of spring, like macam so tuliskan type of spring. Type of spring is also not accepted. Okay, because you cannot measure type. Okay, like actually right here, length of the spring at the start of the experiment, or the initial length of the spring. Okay, initial length of the spring is accepted because we can measure the initial length of the spring. Okay, other than initial length of the spring, what do you think will be the fixed variable? Okay, stiffness of the spring is correct. However, you cannot measure stiffness directly. What do you think will affect the stiffness of the spring? Mass of the plasticine is incorrect. Why? Why we cannot say mass of the plasticine?
Because the mass of the plasticine is the manipulated variable.
Yes, correct. Because we change the mass of the plasticine or the weight of the plasticine, because it is the manipulated variable. Okay. Sorry. Fixed variable is something that does not change apa sepanjang eksperimen. It does not change. For example, like Ashley said, the initial length of the spring. Okay, initial length maksudnya the spring punya length asal lah. Okay, Archana said height of weight. Macam mana height of weight?
Sure, like where's the weight place, the height initially?
Okay, I think the height of weight is incorrect. Okay, because like how you measure from the bottom to the spring, height of weight.
Yes, true.
Okay, you have an idea, but we cannot use height of weight as our variable. Okay, so we have stiffness. Stiffness is correct. However, we cannot measure stiffness directly from the experiment. Okay, and then we have type of spring. Type of spring is not acceptable because we cannot measure type. Okay, what we can measure, like Ashley right just now, is initial length of spring. Okay, if we have a spring that is thicker, what would be the force exerted onto it. A thicker spring and a thinner spring. What is the difference between these two springs? Which one is much easier to extend? Okay, thinner spring is easier to extend. So the diameter of the spring is used as fixed variable. Okay, so position of spring is not acceptable because position is too general. Position mana? Atas, bawah, kiri, kanan. Okay, so for fixed variable, we can use diameter of spring, and also we can use initial length of spring. Okay, so type of spring, please avoid using the word type. Okay, even though we are using the same type, but type, don't use type as variable. Okay, because type we cannot measure. Okay, so these are the manipulated, responding, and fixed variable for the experiment. Okay, so I repeat, you should be able to write the inference based on the situation, general relationship between two variables. And the next one, you should be able to write the hypothesis. Hypothesis is more specific relationship. And then you should be able to write the aim. And then you should be able to write all the three variables. Okay, when we do experiment, you should be able to write all this. Okay, so and also when you do the experiment, you should be able to write the procedure and method. Okay, you should be able to draw this, the arrangement of apparatus, because I'm not very sure how the question would be. Okay, so I think we need to be fully equipped with all the skills that needed to needed in the experiment lah. So you should be able to draw the arrangement of apparatus. Okay, we have a ruler as our measuring apparatus. Okay, and then we have a spring. Okay, pin tu sebagai penunjuk. Okay, so this is the method. Mark the initial position of the pin on the ruler before weight is hung on the spring. Okay, before we hang any weight, we must mark the initial length of the spring. And as you can see here, L naught. L naught is the symbol for the initial length. Okay, you must write the symbol here. Okay, and then hang 50 grams slotted weight on the spring and measure the new length. And as you can see here, L is the symbol for the new length. Okay, so measure the extension of the spring. Okay, as you can see for the procedure, it is apa dia macam mana? Ikut susunan lah. Okay, bila you have a measurement, you have to put a symbol. Okay, so L naught is the initial length, L is the new length, and you have to show how do we get the extension. Okay, because this is not you doing the experiment. Now you are writing how the experiment is being done. Okay, so you need to explain step by step. Okay, so measurement of the extension of the spring is L minus L naught. Okay, and then repeat the experiment with weight 100 gram, 150 gram, 200 gram, and 250 gram. As for the repetition, you need to put at least 4 more different reading. So total for your experiment, you should have 5 reading, 5 different reading. Okay, so when you write your report, okay, the weight, the different weight that you use, you have 5 different weight. Okay, if you write less than 5, you are going to face a problem. Okay, because when you draw a graph, you cannot get a very good graph. For physics, for the paper 3, when you do the experiment, you have to write the report. Okay, you have to write the procedure, you have to draw the arrangement of apparatus, and also you need to draw the graph. Itu yang penting. 45 minutes. All should be done within 45 minutes. Okay. So, precaution step. What do you think should be the precaution step? Jessamine Kaur. Precaution step. Yes, Jessamine? What is the precaution step that we need to take when we do the experiment to have an accurate reading?
The way we read the reading.
Sorry? Okay, so Jasmine right here, I must be perpendicular to the reading of meter rule to avoid parallax error. So that is the what we call as universal precaution step. For all experiment, we can use this. Okay, it's just that you need to change the apparatus. Okay, in here, the apparatus used is a ruler, so you need to write ruler. Okay, ensure the ensure the extension of spring does not exceed half of the original length, so the spring is not overstretched. Okay, so this one is also a precaution step for experiment for spring. Okay, the extension of the spring or the force exerted onto the spring shouldn't exert what we call as ada limit. Kalau tengok dekat textbook dia panggil apa limit, because for elastic object, when you exert force too much, it will cause the object loses its elasticity. Okay, so that particular force up to a certain limit, it is called apa limit saya lupa. Elastic limit. If the force exerted exceed the elastic limit, the object will loses its elasticity. Okay, it won't go back to its original length. Okay, so B said ensure extension of spring does not exceed half of its original length. So half of its original length tu tak sesuai, does not exceed elastic limit. Okay. So that is another precaution step specific to experiment of the spring. Okay, so as I told you before, after you did the experiment, after you get all your result, you have to draw a graph. Okay, and I'm sure for paper 3 experiment, awak memang akan kena draw graph. Okay, so usually for experiment, we draw graph. For the x-axis is the manipulated variable, and for the y-axis is the responding variable. However, specific to this experiment, special case, the manipulated variable, we place it at the y-axis. Nah, ini sahaja. Dan beberapa eksperimen yang special lah. Okay, dia punya manipulated letak dekat Y. Dia punya responding letak dekat X. Okay, biasanya manipulated is at X, responding is at Y. Okay, so for the experiment, yang ni tak cukup data, ada 3 sahaja. Okay, but for your experiment, you should get at least 5 different data. Baru boleh plot graph yang cantik. Okay, so kalau lebih tak apa, lebih boleh, jangan kurang. Okay, for the experiment nanti, bila kita buat eksperimen, apa-apa sahaja eksperimen, all your data should be more or same as 5 or equal to 5. Jangan kurang. Kalau kurang, you will lose mark in your procedure, you will lose mark in your graph. Okay. So, kat sini dia kurang tepat lah. However, this PowerPoint is only to show the gradient. Okay. So, based on the graph, can you please calculate the gradient of the graph? Berapa gradient dia? Boleh tuliskan jawapan dekat chat. Nah, berapa gradient based on the graph? Everybody can see the graph kan? Okay, tapi graph ni terlalu simple lah. 100. Okay, so gradient, we divide the value for y-axis to the value of the x-axis. Okay, so 3 divided by 0.03. So when we draw a gradient, we must first draw the triangle, the biggest triangle we can get. Okay, and then we write the equation, and lastly, we get the value, and don't forget the unit. Okay, I presume that for your SPM, for the paper 3, this would be one of the experiment. Maybe lah, eksperimen yang mungkin. Okay, because this is the first year, so barang-barang tak berapa cukup for eksperimen. Okay, so ada a few eksperimen yang kita boleh dapat barang yang banyak. Example, ni lah, spring. Okay, eksperimen untuk spring. And then eksperimen untuk inertia. Okay, ada beberapa eksperimen yang kita boleh target akan keluar. So, I target yang ini. Sebab dia barang dia mudah dapat, so boleh sediakan untuk individu. Okay, so I presume if this come out, you need to write the inference, you need to write the hypothesis, you need to write the aim, variables, and also arrangement of apparatus you need to draw, and then you need to write the procedure, and then you write the data that you get, your result, and you need to draw graph. All this within 45 minutes. So when you are to draw a graph, you are to calculate the gradient of the graph. So ini saya rasa yang paling susah lah. Tapi mungkin dia akan less than that. Tapi kita fokus pada yang lebih susah, nanti bila soalan tu keluar senang, lebih senang untuk kita jawab. Okay, but when we calculate gradient, we need to make sure our answer come with the correct unit. Okay, how do we do that? Apabila kita buat calculation, okay, so this is this is the unit for the y-axis, kan? Gradient is y divided by x-axis. Okay, unit for y-axis is Newton, and unit for x-axis is meter. Okay, write the unit next to the value so that when you calculate, you will get the correct unit. Okay, n divided by m, or n m negative 1. If you want to leave your answer like this, also can, tak ada masalah. Okay. Okay, so after we, okay, this one is different. Maybe this is not, this won't be asked in the paper 3 punya eksperimen, tapi ini topik yang lain. However, you are to calculate the area under the graph when x is 6 cm with its unit. Okay, x is 6 cm. So this is 6 cm. Okay. This is the area under the graph. So 6 cm. This is the area. Okay, when we calculate the area, what is the formula? Apa formula untuk area?
X times Y.
Okay, x times 5. So since this is a triangle, so it's half x times y. So x is x and y is f. Okay. Okay, half 3 Newton times 0.6 meter. So 3 Newton is the force and 0.56 is the extension. Okay, so you get 0.09 Newton meter. Okay, X is extension. So kalau extension tu kita ambil kira as distance or displacement, it will become S, betul? Displacement. And F times S is work. Okay, to do work, you must exert force that will cause displacement. Okay, work, general formula for work is force times displacement. Okay, so when you calculate the area under the graph for extension, actually you are calculating the work done. Okay, so 0.09 Newton meter, we can also write as 0.09 joule. Okay, work done by the spring to extend. So if we have a graph based on the experiment, the first one we can calculate the gradient. Okay, so we can calculate the gradient, and this is called as spring constant. The gradient is also known as spring constant. Okay, if we have a spring that is identical, the same initial length, the same diameter, the same material, okay, the spring constant would be the same. Even though for this experiment you hang up to 100 Newton and this one you hang up to 50 Newton sahaja, when you calculate the gradient, you should get the same value because same spring will have the same spring constant. Okay, so gradient of the graph for extension of spring experiment is spring constant. And the next one, if we calculate area under the graph, we are actually calculating the work done by the spring. Okay, so when spring exert or when spring do work, the energy used is known as potential energy, elastic potential energy. So this is also known as elastic potential energy. Okay. So for graph, we can identify two physical quantity. One is the spring constant. Okay, sifat spring tu. And then the next one is the elastic potential energy. Elastic potential energy is the energy used to do work to extend the spring or to compress the spring. Okay. So from the graph, what is the relationship between force and the extension of spring? So I presume this would be asked in the paper 3. So based on the graph, what do you think would be the relationship? Samitra. Sorry. Samitra, what is the relationship based on the graph? Yes. Yes, Samitra, I'll wait for you to type your answer. Okay, F is directly proportional to X. Okay, when the question asks from the graph, you have to write the relationship whether it is directly proportional or linearly increasing or linearly decreasing. Okay, based on the graph. Okay, if your graph start from 0, 0, it is directly proportional. So Samitra is correct. The relationship is the force is directly proportional to the extension of the spring. Okay. So the next one, discussion. State the physical quantity represented by the gradient of the graph. Tadi apa yang saya kata? Gradient of the graph is known as Kavitra. Gradient of the graph represent what we call as, apa tadi, Kavitra? Yes, Kavitra? You can switch on your mic or you can type your answer. Okay, not sure. So gradient of the graph. Okay, Kavitra not sure is what is the gradient, what is the physical quantity. Tadi saya baru cakap tadi. Lian, what is represented by the gradient of the graph? The physical quantity is known as Lian?
Teacher, is it the spring constant?
Okay, so gradient of the graph is known as spring constant. Mana pergi? Spring constant. Or the symbol is K. Okay, betul Kinesha. The symbol for the spring constant is K. Okay, and as for area under the graph, what is the physical quantity for area under the graph?
Elastic potential energy.
Okay, so area under the graph, we are calculating elastic potential energy. Elastic potential energy. So these are the two quantity that is being represented by gradient and also area under the graph. Okay, if the question asks you, what is the potential energy when we compress the spring? Okay, so you need to calculate area under the graph if the question come with a graph. Okay, or if the question want us to calculate the spring constant, so you need to calculate the gradient of the graph. Okay, so the experiment for gradient for spring weight and also extension is known as Hooke's law. Hooke's law. Okay, so for Hooke's law, the spelling of Hooke should be correct because this is a person's name. Okay, untuk SPM, there are a certain word that you need to spell it correctly, especially for laws and apa law lagi prinsip. Okay, because usually it is a person's name. Okay, so Hooke's law states that extension of spring is directly proportional to the force applied on the spring provided the elastic limit of the spring is not exceeded. Okay, so this is the definition of Hooke's law. Extension of spring directly proportional to force provided elastic limit is not exceeded. Sorry. Okay, the bigger the mass or the bigger the weight we hang on to the spring, it will extend more. Or the bigger the force exerted, it will compress more. Okay, so for the spring, it is either extension or compression. Okay, tapi kalau awak tengok soalan more on extension. Okay, but as for compression is the same actually. Cuma when compressed, the spring will become shorter. Okay. So Hooke's law, the equation of Hooke's law is F equals to Kx. Okay, where F is the force exerted onto the spring, K is the spring constant, and X is the extension of the spring. Well, actually, this is the graph punya formula lah. Y equals to mx. Kan? Y equals to mx, graph formula. Y is the F axis. F is the y-axis, K is the gradient, and X the x-axis. Okay, so we come with this formula, and it is known as Hooke's law. Okay, so the next one is to analyze graph of X against X to determine the value of spring constant and elastic potential energy. So just now, what is known or what is the definition of elastic potential energy? Apa tu elastic potential energy? We know that to calculate elastic potential energy, we get it from the gradient of the graph. But what is the definition of elastic potential energy? Who knows? Siapa boleh bagi definition of elastic potential energy? Dari tadi saya panggil Lian, tak ada respon. Lian, where are you? Elastic potential, work done to stretch the spring. Okay, so it can define as work done to stretch or compress the spring. Or it also can be defined as energy stored or energy possessed by elastic material. Okay, so when we do work, we use energy. So energy and work is interchangeable. We can use the word energy, we can use the word work. Okay, so here energy possessed by an elastic material, or like Abi said, work done to stretch a spring or to compress a spring. So what about spring constant? What is the definition of spring constant? Nadia Natasha. What do you think is the spring constant, definition of spring constant? Stiffness of spring. Okay. Or we can see that directly from the graph, force required to extend 1 unit of extension of spring. Force required to extend 1 unit of extension of the spring. Okay, definition of spring constant. And spring constant is also known as stiffness of the spring. Okay, Shena, how to pronounce your name? Sneha. Sneha said it's a measure of the elasticity. Okay, measurement of elasticity. Or we can, for your syllabus now, we seldom use the word elasticity. Okay, macam previous punya KBSM, kita sebut is more elastic, less elastic. Okay, sekarang kita guna stiffness. So, stiffer or less stiffness. Okay. So macam Kavitra tadi kata, stiffness of the spring. Spring constant also known as the stiffness of the spring. But definition of spring constant is force required to extend 1 unit of extension of spring. Now, for the elastic limit of spring, it is defined as maximum force that can be applied so that the spring will return to its original length if the force is removed. So this is elastic limit. Okay, when you have an elastic object, you can stretch it or you can compress it, but not more than its elastic limit. Because if the force exerted is exceed the elastic limit, the spring, the sponge, or the elastic material cannot return to its original force. Okay, so we stop here. Next week, we have another class on Friday. And next week, please remind everybody that we are going to have a PBD test. Okay, PBD test to determine your band. And the question is up to band 6. Okay, so please tell everybody untuk next week kena join class and saya akan beri test test masa tu juga yang you akan submit dan saya akan mark untuk dapatkan band untuk PBD. Okay, so we stop here. And for those who haven't submit your exercise on the Google Classroom, please do so. Okay, and for those who have already sent in, I dah mark, dah pulang balik. Please check. Okay, so kita stop dulu with that. Thank you, class. Okay.
Teacher, the PBD test is next week or this Friday?
Next week.
Next Tuesday.
Because next week you are going to get a new timetable. So I tak tahu bila hari apa.
Oh, okay. Thank you, teacher.
Okay.